Hello everyone. This is Jiawei Zhang, and next we will present our work on fake detector on the effective fake news detection with deep diffusive neural nets. This is a joint work with Bo Wendong and Philip Yu. So we are from the Florida State University as well as the University of Illinois and Chicago. So first of all, what is fake news? Fake news denotes actually a type of praise which intentionally presents misinformation spreading through both the traditional print news medium as well as the recent online social medium. We have different kinds of fake news in the history as well as in nowadays. So according to the records, the first fake news in the print medium comes from the Sun actually, which is about the Great Moon Hoax. It is a series of 6 articles published by the Sun in 1835 about the supposed discovery of life and even civilizations on the moon. At that time, people think this is true actually. However, later on, as we sent more people and satellites to the moon, we find it's fake because no people living on the moon. Besides the history, we also have so many different kinds of news and messages spreading in both print medium and social medium nowadays. Some of them can be true, some of them can be fake, and we show some examples at the bottom about the Trump-Russia investigation, the Trump-Ukrainian scandal, and the Hillary Clinton emails. And many of them we still don't have any ground truth to justify whether they are true or not. So in this paper, we focus on detecting the fake news from a political news article dataset. We call a dataset is called PolitiFact, and it is actually a very complex network involving different kinds of nodes as well as connections among the nodes. We formulated this kind of dataset as a heterogeneous network involving creators, news articles, and subjects as the nodes. We also involve the links among them as its connections. And according to our dataset, we show some basic statistical numbers and information on the right-hand side. So for our dataset, we have more than 14,000 news article nodes and more than 3,600 creators and 152 subjects. We also have a larger number of links among them. So for all the news articles in our dataset, they are labeled into 6 classes by some professional editors. And the news articles are labeled as true, which denotes the completely true news articles, and mostly true, half false, mostly false, and even pants on fire, which denotes completely wrong or fake news articles. So we don't justify whether these labels are true or are correct or not. We use them as a ground truth for our model building, and we will show some results later. Prior to introducing the models, we do some analysis about our datasets. First of all, we show the word cloud of the news articles used in both true articles and fake articles. So according to the frequent words used by different kinds of news articles, we find they have some patterns. For example, in the true news articles, the most frequent words are the American, billion, president, tax, and income, etc. And in the fake news articles, we have more people names, like Obama, Clinton, and the Republican, for example. So it seems that the numbers or some information about the numbers are more frequently appears in the true articles. However, in the fake news articles, they use more names about either people or the parties. So besides the content of the news articles, we also do some analysis about creators. In this page, we show the statistical information of the news articles about some creators, including Trump, Pence, Obama, and Hillary Clinton. According to the dataset, it seems that news articles from the people in the Republican are biased to be fake. However, for the news articles from the Democratic, it seems their news articles are more biased to be correct or to be true. We don't know if it is a bias created by the website, the data set or not. However, we will take this as a ground truth for model building. It also shows that the creators may matter for the detection of the fake news. Besides the creators and the contents of news articles, we also do some analysis about the subjects. According to our studies, we find that the news articles about the topics like about health, they are more biased to be fake. However, for the news articles about some numbers like economy or tax, they are biased to be true. It shows that the subject may matter in justifying the news articles whether they are true or not. And for some other news articles, they are they're balanced. Half true, half false, for example, the jobs, like that. And so therefore, we may also want to include the subjects into the model building so as to detect the fake news from the true ones. According to the previous analysis, we find that both the contents, the creators, and subjects, they all matter. So therefore, we plan to include all of them into the model building so as to detect the fake news from the real ones. So in this page, we show the problem statements, and we aim to infer the labels of news articles from the heterogeneous information. So formally given a graph denoted as G with node set V as well as edge set E, we want to predict the labels of nodes in the set V. So the data we have is a heterogeneous graph. The nodes in the node set V can include news articles, creators, subjects, and the link E includes the links between news articles and subject, as well as news articles with creators. So for the nodes in our dataset, they can have some textual contents. So for example, for news articles, we have news content. For the creators, we have their profile, which is also a piece of textual descriptions. For the subject, we also have some textual contents about subjects. So to solve the problem, we propose a new model, which is called deep diffusive neural nets. It's a graph neural network model. And we plan to utilize both the textual content and the heterogeneous graph structure for the nodal classification task. And we introduce some components for the representation learning with both explicit features and some latent nodal features. And we will fuse them together with a new gate or with a new unit. It's called gated diffusive neural nets, or it's called gated diffusive unit, or GDU for short, for node state representation learning and upgrading and updating. And the model will be learnable via the backpropagation algorithm. In this page, we show the unit to use for the feature representation learning. Generally, given a piece of textual input, we can extract both the explicit features as well as latent features with two small components in the HFLU unit. So based on a set of pre-extracted word states, we can extract some explicit features, like as backup words, from them. They can either be weighted with TF-IDF, for example, and we can represent the extracted explicit features as XIE. I denotes the index of the news articles or the creator or the subject. E denotes explicit. And based on the same textual input, we can also use the LSTM to extract some latent features, which is denoted as XI with L as a superscript. So both these two acts will be fused together. They will be concatenated together and serve as input for the gated diffusive unit. In this page, we show the gated diffusive unit. For the X on the left-hand side, it denotes the feature input, which is a concatenation of XIE and XIL extracted in the previous page. And we have ZI and TI as two other input portals. These two portals are used to get the input from some other nodes. So for example, if we are modeling the states of news articles, the XI will be the features learned from the news article, and XI and the ZI can be the input portal for the subject, and the TI can be the portal for the creators. And all the information from these kinds of heterogeneous neighbors will be fused together with multiple gates in the GDO, and finally they will be fused together and have one unified output, which is HI, models the states for the news article. So based on both the HFLU and the GDO, we can represent the final model of the framework as shown here. Generally, given a heterogeneous graph inputs, we can define a model architecture with a very similar structure as shown on the right-hand side. So based on the input, and we use HFLU and GDO to do the feature extraction and the information fusion. And as finally, the the latent states will be outputted as the two random labels, which is Y denoted in this plot. So in this page, we show the experimental settings we use to testify the performance of our proposed models. And FAKEDETECT is our final approach, and we compare our method with a bunch of baseline methods as shown in this page. So for example, we compare with CNN, we compare with LIWC, we compare with TreeFind, as well as this deep work, 9, label propagation, RNN, SVM, for example. And we evaluated the model performance with several different kinds of evaluation matrices. So we do study both the binary classification problem. We classify whether true or fake of the news articles, and we can also do the multi-class classification. We classified 6 classes as mentioned before. As to the evaluation matrices, we can use accuracy, the macro F1, macro precision, and macro recall to evaluate the performance of the methods. Because the time is limited, so therefore we only show the multi-class classification results in this page. And according to the scores, our method FAKEDETECT can achieve the highest score of all these 4 different matrices compared with the baseline methods. As well, also the gap is very significant compared with the baseline methods. It shows that our method can outperform can solve the problem very well, and can also detect the fake news from the true ones. Because we are studying the multi-class classification, and we also have the binary classification results in our paper, you may refer to our paper for more information. So this is pretty much about the talk, and if you have any questions about the paper, about the models, about data set, welcome to let me know, and you can send me an email to my contact author address as shown in this page. And thanks for your attention.